All right, so let's talk factoring by grouping. Now, factoring by grouping, you can't do in all polynomials. Sometimes it may not work. But the ones that I give you, it will. So when you see something with four terms in it, that's typically a polynomial that you can factor with factoring by grouping. Now they're not, they can't all be factored. But again, like I said, the ones that they give you, you can be factored by grouping. Now they call it factoring by grouping because, well, the first step, what you're going to do is you're going to group the first two together and the last two together. So we have that. Now what we're going to do is factor the first two and the last two, just like what we were doing by the greatest common factor. So maybe just ignore to the right of that little squiggly line for a sec, and let's see, what can I divide out of 2t to the third, 6t squared? Well, 2 and then t squared. And then, bing bing, okay, what times 2t to the squared will give me back those two monomials? Well, I got a t and then plus 3. Because t times 2t squared will give me 2t to the third, 2t squared times 3 will give me 6t squared. Okay, so we have that. Now, we can ignore the left side of the squiggly line, look at the right. What can I divide out of 3t and 9? I can divide 3 out, and it's a positive 3, so we'll put a little plus. And then, in those parentheses, I'm going to have a t plus 3. So hopefully factoring by greatest common factor is getting a little faster now, now that you've seen a few problems. Okay, so once we have those two, we factor the first two, we factor the last two. Notice how what I have in the parentheses here is exactly the same. So that's what we want to happen. So if you're going through one of these problems and they're kind of different, maybe look at the greatest common factors that you found. Maybe it wasn't quite the right one. Maybe on one of them you could have divided a bigger number out of it, or you could have divided more of like a t to the third instead of t squared or something like that. But this is what it's going to look like, t plus 3, t plus 3. Now when those are in common, what you're going to do is take what's in front and you're going to put that in one set of parentheses. Just like that. So you notice how you have the 2t squared, you have the 3, and then you're going to multiply it by that common binomial. And bam, there you go. Now, if you guys remember foiling, what you could do is foil this all out, and what you would get is that original one there. So like I said, factoring is breaking up a polynomial into two simpler polynomials that when you multiply them together gives you back your original one. So let's take a look at a few more. So again, I'm going to move this second problem down. Factor the first two terms and the last two terms separately. So what can I divide out of 3 to the fourth and 2 to the third? Well, there's no real numbers, but I can divide n to the third out of both. So I got 3n and then plus a 2. And what can I divide out of 15n and 10? That'll be a 5, positive 5. So that'll be 3n plus 2. Okay, and once again, hey, we got the same things here. So only because that happens, I can bring these front ones together. So on these grouping problems, they'll all work out like this, fortunately for your sake. But if those two were different and you couldn't simplify it anymore, don't do the step. So n to the third plus 5 times 3n plus 2, because that's my common binomial. All right, next one. Factor by the greatest common factor, the first two and the last two separately. So I can divide an n squared out of both of these, so that'll give me an n plus 3. And I can divide a 4 out of both of those, so that'll give me an n plus 3 as well. And once again, these are in common. So I can take those ones in front and bring them together. So n squared plus 4 times that common binomial n plus 3. So that goes there. Let's see. Looking at these. And you notice that some of them are negative, so see what happens with these problems. So what can I factor out of that? N to the third. So we have 3n plus 2. And what can I divide out of negative 15n and negative 10? Now you can look at this a couple different ways. So what I'm going to do is I'm going to divide out a 5. Okay, so 5 times what will give me a negative 15n. Make sure to put that negative with it. And that'll be a negative 3n. And 5 times what will give me a negative 10, that'll be a negative 2. Now notice how this and this are not exactly the same. So right now I cannot bring those numbers in front together. Not yet. But notice how they're very close. The only difference is that I have a positive 3n and a negative 3n. I have a positive 2 and a negative 2. So what you're going to do, and here's this little trick that you can do. Make the 5 out front not positive. Let's make it negative. And that causes this one to be positive in order to get a negative 15n. And this 2 will have to be positive in order to get a negative 10 here. So you can do it the way I did, or you could have just divided out negative 5 in the first place. So however you want to think about it. Now that these are the same, I can take what's in front and bring them together. So n, keep writing m's for some reason, n to the third minus 5, keep that negative with it, times 3n plus 2. And there's my answer. So once again, factor these by greatest common factor. I got a 2y squared, and then a y plus 2. And let's factor out 3, so that'll be a negative y minus 2. And once again, these two are almost the same, just the signs are different. So let's make this 3 a negative. And that'll cause this to be a positive, that to be a positive. Now I can bring those in front together. 2y to the second minus 3 times y plus 2. And one last one. Looks a little different. Actually, I'm not sure what's different about this one. We'll see if it actually is or not. So I can divide 5 and x squared. Then I have a 3x plus a 4. And then, oh, I see how this one's different. So 3x and 4, there really isn't anything you can divide out, so it's just like a 1. Okay, and then I have 3x plus 4. That's what's different about this one. There isn't anything I can really divide out of these two besides a 1, so that's okay. Just divide out that 1. And now, these are in common. Bring these together in one set of parentheses. So I have 5x squared plus 1 times the common variable, 3x to the plus 4. And there we have it.